In the early 1900s, the United States Navy was suffering from a midlife crisis before it even reached maturity. The Spanish-American War had proven that the U.S. could hold its own on the world stage, but technology was moving at a localized warp speed. Naval architects were obsessed with a single, dangerous idea: concentrated firepower. They wanted the biggest guns in the smallest space with the least amount of weight. And in 1901, the Bureau of Construction and Repair moved forward with a design that seemed like a stroke of genius, but would soon become a cautionary tale. Instead of placing the secondary 8-inch guns alongside the main 12-inch battery in separate locations, they decided to bolt the 8-inch turrets directly on top of the 12-inch ones. It looked like a marvel of efficiency, a futuristic solution to the limits of deck space. But for the sailors who had to fight inside these steel boxes, the USS Virginia, BB-13, was a claustrophobic, deafening, and tactically paralyzed nightmare. To understand why the Virginia was built this way, you have to understand the era of the pre-dreadnought. In the late 1892s, battleships were designed like Swiss Army knives. You had your main battery, usually 4 massive 12-inch guns meant for sinking other capital ships. Then you had your intermediate battery of 8-inch guns meant to pepper the enemy's superstructure and destroy their ability to steer or communicate. Finally, there was a secondary battery of 5 or 6-inch guns to fend off the era's newest threat, the torpedo boat. The problem for designers was weight and the arc of fire. If you put 8-inch guns in turrets on the sides of the ship, known as the waist, they could only fire at targets on that specific side. If the enemy was on your port side, your starboard guns were just dead weight, doing nothing but adding displacement and slowing the ship down. Enter the concept of the superposed or stacked turret. The logic was deceptively simple and, on paper, incredibly persuasive. By stacking the 8-inch turret on top of the 12-inch turret, both sets of guns could rotate together. This allowed the 8-inch guns to fire across a 270-degree arc, the same as the main battery. It theoretically gave the ship a massive broadside regardless of which direction it was facing, while saving hundreds of tons of armor plating because the Navy only had to protect one vertical column of machinery instead of 2 or 3 separate locations. When the Virginia class was first drawn up, it was heralded as the most heavily armed ship of its displacement in the entire world. It was a king of paper statistics, but the physics of the real world were about to intervene. When the USS Virginia was commissioned in 1906, the engineering reality of the stacked design hit the crew with devastating force. The most immediate issue was the interference problem. In a standard turret, there is a direct, clear line from the powder magazine to the guns. In a stacked turret, you had 2 different crews, handling 2 entirely different sizes of ammunition, all crammed into the same central rotating structure. This created a logistical bottleneck that slowed the rate of fire for both sets of guns. But the mechanical chaos was nothing compared to the blast overpressure. If you were a gunner in the upper 8-inch turret, your world ended the moment the 12-inch guns below you fired. The concussion didn't just shake the ship. It created a massive vacuum of pressure and a cloud of acrid brown powder smoke that was sucked directly back into the upper turret's sighting hoods. Official records from early gunnery trials noted that the 8-inch crews were often momentarily stunned or even blinded by the discharge of the larger guns directly beneath their feet. The vibration was so intense that it often knocked the delicate optical sights of the 8-inch guns out of alignment every time the 12-inch guns fired. This meant you couldn't actually fire both sets of guns independently with any degree of accuracy. If the 12-inch guns were engaging a target, the 8-inch guns were effectively useless until the smoke cleared and the crew stopped reeling from the shockwave. Essentially, the Navy had built a ship with more guns, but it had created a system where those guns actively sabotaged one another. Beyond the internal chaos, there was the looming threat of the metacentric height, the ship's fundamental stability. By placing the heavy 8-inch guns, their thick armor, and their complex turning machinery so high above the waterline, the Virginia and her sister ships, the Nebraska, Georgia, New Jersey, and Rhode Island, became notoriously tender. They rolled heavily in even moderate seas. Because the 8-inch turrets were perched so high, the rolling motion was amplified for the gunners at the top. Trying to keep a telescope on a target while your turret is swinging through a 15-degree arc is an exercise in futility. The Navy had traded stability for theoretical power, and they had lost the bet. Even as the Virginia left the shipyard, a new ship was being built in Great Britain, the HMS Dreadnought, that would make the Virginia's entire mixed-caliber philosophy obsolete before it ever saw a day of combat. The strategic failure of the Virginia class was compounded by the fact that the United States was stubbornly clinging to an old way of thinking just as the rules of naval engagement were being rewritten. While American designers were trying to perfect the mixed battery concept with their stacked turrets, the rest of the world was realizing that long-range gunnery was the only thing that mattered. In the old days, ships fought at pistol range, roughly 2,000 to 3,000 yards, where the 8-inch guns could actually penetrate armor. But by 1905, engagement ranges were opening up to 6,000 and 8,000 yards. At those distances, the 8-inch shells simply didn't have the kinetic energy to do damage, yet they created so much splashes in the water that the spotters couldn't tell which splash came from the 12-inch big guns and which came from the smaller ones. This created a fire control fog that made the Virginia nearly impossible to direct in a long-range duel. The tactical nightmare of the stacked turret was further exposed during the voyage of the Great White Fleet, when President Theodore Roosevelt sent 16 battleships around the world in 1907 to flex American muscle. 5 of those ships were Virginia-class vessels. On the surface, they were the stars of the show, gleaming white hulls and buff-colored upperworks that looked majestic in foreign ports. But behind the scenes, the crews were struggling. The stacked turrets were a constant maintenance headache. The massive weight of the 8-inch turret sitting on the 12-inch roof placed immense strain on the training gears and rollers. If the ship developed even a slight list, the heavy turrets were difficult to turn, and in some cases, the electric motors would burn out trying to rotate the thousands of tons of steel against the force of gravity. While the world saw a display of strength, the engineers inside the Virginia were discovering that their innovation had created a ship that was mechanically fragile and prone to breakdown under the stress of a global voyage. As the Great White Fleet moved from port to port, the news of the HMS Dreadnought began to sink in. The British ship had done away with intermediate batteries entirely, opting for 10 12-inch guns and nothing else. This made the Virginia's stacked turrets look like a relic of a bygone era. The Americans had spent millions of dollars and years of development on a design that was effectively dead on arrival. The Virginia and her sisters were pre-dreadnoughts in the truest sense, ships that were built for a style of warfare that ceased to exist the moment they hit the water. The stacked turret, which was supposed to maximize firepower, had instead maximized the ship's vulnerability by concentrating all its offensive capability into 2 tall targets that were easier for an enemy to hit and more difficult for the crew to operate. By the time the Virginia-class ships returned from their world tour, the Navy was already looking for a way to phase them out. During the 1,910 seconds, they were relegated to training duties and experimental roles. The very thing that was supposed to be their greatest strength, their unique armament, made them unsuitable for modernization. You couldn't simply fix the stacked turret. The entire hull was designed around those specific weight distributions. To remove the 8-inch guns would have required a total reconstruction that would have cost as much as building a new ship. Consequently, as the United States entered World War I, these engineering nightmares were mostly kept in home waters, used for training gun crews for the newer, more capable dreadnoughts that had finally replaced them in the line of battle. The final insult to the Virginia class came in the early 1,920 seconds, following the Washington Naval Treaty. These ships, which had been the pride of the fleet just 15 years earlier, were now considered surplus and a waste of manpower. But even in death, the Virginia served as a test subject for a new kind of failure, the vulnerability of the battleship itself. In 1923, the USS Virginia and the USS New Jersey were towed off the coast of Cape Hatteras to serve as targets for General Billy Mitchell's Army Air Service bombers. The Navy watched in horror as the once mighty battleships, with their complex and heavy turret systems, were pummeled from above. Within minutes of the attack starting, a 1,100-pound bomb struck the Virginia directly. The ship that was designed to be a fortress of concentrated fire became a mangled wreck of steel, rolling over and sinking in less than 30 minutes. Ultimately, the USS Virginia stands as a monument to the dangers of feature creep in military engineering. It was a ship designed by committee, trying to satisfy too many conflicting requirements at once. It tried to be a heavy hitter, a fast cruiser, and a weight-efficient marvel, but it ended up being a compromise that satisfied no one. The stacked turret was a clever solution to a problem that shouldn't have existed in the first place. If the designers had focused on a simpler, more robust layout, the Virginia might have been a legendary fighter. Instead, she remains a footnote, a reminder that in the world of naval architecture, sometimes more is just a more complicated way of failing. To truly grasp why the Virginia was a failure, we have to look inside the steel skin of the turrets themselves, where the trial-by-fire gunnery reports of 1,909 paint a grim picture of daily life. Inside the 12-inch lower chamber, the space was already cramped with the massive breeches of the Mark V guns. However, because the 8-inch turret was superposed above, the central column, the vertical spine that carried the ammunition, was twice as crowded as a standard ship. You had two separate hoists running parallel to each other. If the 8-inch hoist jammed, which it frequently did due to the vibration of the ship's engines, the technicians had to climb into a space that was dangerously close to the 12-inch loading tray. It was a mechanical death trap. During high-speed firing drills, the heat generated by the cordite charges in such a confined, poorly ventilated vertical space was so intense that powder crews often fainted, leading to a dangerously sluggish rate of fire that would have been fatal in a real naval engagement. The gunnery reports from 1909 specifically highlight the flicker effect that baffled American officers. When the 8-inch guns were fired, the blast gases would wrap around the turret and obscure the 12-inch range-finding telescopes for several seconds. In the world of naval gunnery, several seconds is an eternity. By the time the smoke cleared, the enemy ship had moved, and the range had changed. If the 12-inch guns fired first, the sheer physical shock would often jump the 8-inch guns out of their elevation notches. Imagine a sniper trying to take a shot while someone is hitting the bottom of their rifle with a sledgehammer. That was the reality of the Virginia. The Navy's own Bureau of Ordnance eventually admitted that the combined rate of fire for a stacked turret was actually lower than that of a ship with half the guns in a standard configuration. They had doubled the barrels but halved the efficiency. The social hierarchy on the ship was even fractured by this design. The upper turret crews and lower turret crews were technically part of the same division, but they operated in total isolation from one another, communicating only through voice tubes that were often drowned out by the roar of the machinery. This led to command and control chaos. If the lower turret captain saw a target of opportunity, the upper turret captain might be looking at something entirely different. Without a unified sighting system, which didn't exist yet, the two sets of guns were often aiming at two different points on the horizon, despite being physically bolted together. It was a tactical schizophrenia that made the Virginia a nightmare for the ship's gunnery officer to manage from the conning tower. As the 1909 trials concluded, the data was undeniable. The superposed turret was a dead end. While the U.S. Navy would try the concept one last time with the Kearsarge and Kentucky, and later a refined version of superfiring, where one turret is simply placed behind and above another, rather than bolted on top. The stacked experiment died with the Virginia class. The older sailors who manned these ships often spoke of the Virginia shake, a specific, violent shudder that ran through the keel whenever a full broadside was attempted. It was a vibration that felt like the ship was trying to shake itself apart, a physical protest against a design that defied the common-sense laws of physics and naval warfare. By the time the Virginia was scrapped or sunk as a target, she had become a ghost of an era that valued complexity over reliability. For the veterans who served on her, she wasn't just an engineering nightmare. She was a lesson in humility for a rising global power. The ship proved that in the cold, salt-sprayed reality of the North Atlantic, a simple, reliable gun is worth 10 innovative ones that don't work when the shooting starts. The Virginia didn't lose a war against a foreign enemy. She lost a war against her own blueprints, proving once and for all that in naval architecture, the most dangerous enemy is often the man with the pen and the drafting table. The legacy of the Virginia-class failure didn't just end with a sunken hull off the coast of North Carolina. It fundamentally reshaped how the United States Navy approached the dreadnought race. The humiliation of the superposed turret experiment forced a complete cultural shift within the Bureau of Construction and Repair. They moved away from the Swiss Army knife philosophy and toward the standard-type battleship concept ships that emphasized uniform speed, uniform turning circles, and, most importantly, simplified all big gun armaments. The Virginia taught the Navy that an intermediate battery was a liability in the age of long-range fire control. By 1916, with the arrival of the Nevada class, the U.S. had perfected the super firing arrangement, placing one turret behind and above another, but entirely separate, which provided the same 270-degree arc of fire without any of the mechanical or blast interference that had plagued the Virginia. The post-mortem of the Virginia design reveals a fascinating historical irony. While the American public saw these ships as symbols of an emerging empire, the Navy's top brass was privately terrified of their performance. In confidential memos, Admiral William Sims, a champion of gunnery reform, used the Virginia as his primary exhibit for why American naval design was lagging behind the British. He pointed out that the open ports and shared ammunition hoists in the stacked turrets were invitations to catastrophe, noting that a single lucky hit from an enemy shell could ignite the powder charges for 8 guns, simultaneously, likely causing a magazine explosion that would vaporize the ship. The Virginia was, quite literally, a powder keg with a design that made a catastrophic fire almost impossible to contain. This engineering nightmare also served as a catalyst for the development of modern fire control. Because the Virginia was so impossible to aim, the Navy was forced to invest heavily in the development of centralized plotting rooms and mechanical computers. They realized that if the hardware was going to be this complicated, the software, the methods used to calculate range and deflection, had to be revolutionary. The failure of the stacked turret proved that the human eye and a simple telescope were no longer enough to manage the chaos of a modern naval battle. This led to the creation of the Ford Rangekeeper and other early mechanical computers that would eventually give the U.S. Navy a decisive edge in the Pacific during World War II. Even the end of the Virginia was a lesson in the changing nature of power. When General Billy Mitchell's bombers sent the Virginia to the bottom in 1923, it wasn't just a victory for the Air Force. It was a final confirmation that the pre-dreadnought era was truly dead. The ship that was meant to be the ultimate expression of surface firepower was sunk by a handful of biplanes carrying primitive, dumb bombs. The Virginia's heavy, top-heavy turrets actually accelerated her demise. Once the hull was breached and the ship began to list, the massive weight of the stacked 8-inch guns acted like a lever, pulling the ship over and causing her to capsize far faster than a more balanced vessel would have. Today, the USS Virginia, BB-13, is remembered by naval historians not for what she achieved, but for what she cautioned against. She is the ultimate case study in why more isn't always better. She was a ship that tried to bridge 2 centuries and failed to satisfy either. The stacked turret was a brilliant answer to a set of technical constraints, but it ignored the most important element of any weapon system, the human being inside it. As we look back at the grainy photos of the Virginia steaming with the Great White Fleet, we see a ship that looks powerful, but we now know the truth. She was an engineering nightmare, a mechanical tragedy, and the most expensive lesson the U.S. Navy ever had to learn. To truly understand the depth of the Virginia failure, we have to look at the specific metallurgical and ballistics data that drove the Navy into this corner. At the turn of the century, the U.S. Navy was using brown powder, a precursor to the more stable smokeless powders we see today. Brown powder was notoriously dirty and inconsistent. When the Virginia's twin 12-inch guns fired, they released a massive, dense cloud of sulfuric smoke that would hang over the water like a physical curtain. Because the 8-inch turret was physically attached to the 12-inch turret, its sighting hoods were located just a few feet above and behind the muzzles of the larger guns. This meant that the secondary battery was essentially blinded by the light of its own parent turret. In naval exercises off the Virginia Capes in 1907, observers noted that the 8-inch gunners were frequently forced to wait up to 40 seconds for the brown fog to clear before they could even reacquire their targets. In a real-world combat scenario against a fast-moving cruiser, a 40-second delay was the difference between a victory and a sinking. The internal layout of these turrets was a masterpiece of Victorian-era over-engineering that created a lethal environment for the Black Gang and the gun crews. In a standard turret, the ammunition hoists were isolated by armored shutters to prevent a flash fire in the gunhouse from reaching the magazines below. However, in the Virginia's superposed design, the 8-inch ammunition had to pass through the 12-inch handling room. This meant that the armored integrity of the ship's most vulnerable area was constantly compromised. There were open apertures in the floors and ceilings of the turret structure to allow for the movement of two different sizes of shells and two different types of powder bags. If a shell had struck the 8-inch turret, a fire would have had a direct, uninhibited path down into the 12-inch magazine. The Navy was essentially building chimneys that led straight to their own explosives. This flash fire risk was the primary reason why, after only a few years in service, the Bureau of Navigation issued a standing order that the 8-inch guns were never to be fully loaded, while the 12-inch guns were in high-speed operation. The mechanical strain on the ship's electrical system was another silent killer of the Virginia's efficiency. These ships were among the first to move away from hydraulic turret training to electric motors. But 1901-era electric motors were not designed to rotate the massive, unbalanced weight of a double-decker turret. The weight distribution was notoriously off-center. When the guns were elevated, the center of gravity for the entire turret shifted forward, putting immense torque on the central spindle. During sea trials, engineers found that if the ship was rolling more than 5 degrees, the electric motors would groan and spark, often tripping the primitive circuit breakers of the era. Sailors reported that the smell of ozone and burning copper was a permanent fixture of life inside the Virginia. This meant that in a heavy sea, the exact environment where a battleship is supposed to thrive, the Virginia's primary weapon system was prone to total electrical failure. When we talk about the tactical disaster of the Virginia, we have to mention the concept of the danger space. In the early 1900s, hits were achieved by estimating the range and firing a shell in a high arc so that it landed on the enemy's deck or hull. Because the 8-inch guns and 12-inch guns had different muzzle velocities and different shell weights, they had completely different ballistic trajectories. They were aimed using the same rotation, but they required different elevation settings. This created a nightmare for the spotter. In the heat of battle, a spotter would see 2 sets of splashes in the water. One set might be from the 12-inch guns, the other from the 8-inch. Because they were fired from the same physical location, the splashes often overlapped. The spotter had no way of knowing which gun was firing long and which was firing short. This rendered the entire concept of walking the fire onto a target impossible. The Virginia was a ship that was literally arguing with itself on the battlefield. The social history of the Virginia is just as telling as its technical specs. The superposed ships were often called the double-deckers by the rest of the fleet, and not in a complimentary way. Life aboard the Rhode Island, or the Georgia, was considered a punishment detail by many in the Navy. The ships were wet, meaning they took on a lot of water over the bow due to the immense weight of the forward stacked turret pushing the nose down into the waves. The crew's quarters forward were perpetually damp, leading to high rates of respiratory illness among the sailors. This wasn't just a matter of comfort, it was a matter of readiness. A sick, exhausted crew cannot operate complex machinery. The Virginia-class proved that you cannot design a ship in a vacuum. You have to design it for the humans who will live in it for months at a time. The death of the Virginia-class was accelerated by the 1922 Washington Naval Treaty, which sought to prevent a global arms race by limiting the total tonnage of the world's navies. When the U.S. negotiators looked at their list of ships, the Virginias were the first to be sacrificed. They were considered white elephants. They were only 15 years old, young by battleship standards, but they were so fundamentally flawed that they weren't even worth keeping in the reserve fleet. While older, simpler battleships, like the USS Arkansas, would go on to serve with distinction in World War II, the Virginia was sold for scrap or used as a target before the 1,920 seconds were even over. The Navy was so eager to rid itself of the superposed embarrassment that they didn't even bother to preserve one as a museum ship. As we look at the wreckage of the Virginia on the ocean floor today, we see more than just a failed experiment. We see the birth pains of the modern American Navy. The failure of the Virginia forced the U.S. to stop copying European trends and start developing its own unique school of naval architecture. It led to the all-or-nothing armor scheme and the standardized fleet that would eventually win the greatest naval war in history. The Virginia was the sacrifice that had to be made so that ships like the USS North Carolina and the USS Iowa could exist. It remains a textbook example of why innovation without practical testing is a recipe for disaster. It is a reminder that in engineering, as in war, The simplest solution is usually the one that keeps you alive. The final lesson of the Virginia is one that still resonates in modern military procurement: the danger of the golden hammer. When you have a new technology like the electric turret motor or the superposed design, you want to use it for everything. You see every problem as a nail that needs that specific hammer. The designers of the Virginia were so enamored with the idea of saving weight and maximizing arcs of fire that they ignored the basic laws of physics and the limitations of the human eye. They built a ship for a world of mathematics, but it had to fight in a world of salt, smoke, and steel. The Virginia didn't just fail as a ship, it failed as a philosophy. And in that failure, it ensured that the U.S. Navy would never again prioritize cleverness over combat effectiveness.